Good morning, students. Welcome back to the online computer class. This video is the third part of your computer chapter, Number System. Let's take a look what we studied in our previous session. In our previous session, we read about octal number system and to convert octal number into decimal number. Then we read about hexadecimal number system, in which we read how to convert hexadecimal number to binary decimal number, and then we read about the introduction of binary arithmetic. So students, let's now discuss the homework of previous session. The homework was to convert these numbers into decimal number. The first number is 321 to the base 8. Since it is octal number system, we will use here 8 as the base. Now, according to the rule, students, we will multiply 3 with 8 to the power 2, 2 with 8 to the power 1 and 1 with 8 to the power 0. By adding these, we will get 192 plus 16 plus 1. In the result, we will get 209. So 321 in octal is equivalent to 209 in decimal number system. The second number was 152 to the base 8. Again we will do the same procedure. We will multiply 1 with 8 to the power 2, 5 with 8 to the power 1, 2 with 8 to the power 0. By adding these, we will get 64 plus 40 plus 2. The result will be 106. Now we have 1, 2, a to the base 16. From here we have hexadecimal number, so we will use 16 as its base. So to convert it into decimal number, we will multiply 1 with 16 to the power 2, 2 with 16 to the power 1, 10 with 16 to the power 0. Since we know from hexadecimal to decimal conversion table, the value of a is 10. So we are going to use 10 here. Now by adding these values, we will have 256 plus 32 plus 10, which will be equal to 298. So 128 to the base 16 is equivalent to 298 in decimal number. The last one is 30b to the base 16. To convert it into decimal, we will multiply 3 with 16 to the power 2, 0 with 16 to the power 1 and 11 with 16 to the power 0. The value of b is 11 from hexadecimal to decimal conversion table. Now by adding these, we will get 768 plus 0 plus 11, which will result into 779. So 30b in hexadecimal is equivalent to 779 in decimal. Now students, we will see what we are going to cover in today's session. In today's session, we will cover binary addition, the rules which we are going to use in binary addition and binary subtraction, and the rules which we are going to use in binary subtraction. Now let's start with the binary addition. Binary addition is very much similar to the decimal addition. In addition, we have to add two or more numbers. So it means in this also, that means in binary addition also, we will add two or more binary numbers. Rather, it is simpler than decimal addition as it involves only 4 possible addition of bits. We know that in our binary digits, we have only 2 digits, that is zeros and ones. That's why in binary addition, we have only 4 possible combination of zeros and ones. Now we have some values, rules for binary addition which you need to note down. Okay, these are 4 rules. 0 plus 0 is equal to result into 0, 0 plus 1 will result into 1, 1 plus 0 will result into 1 again, and 1 plus 0 is equal to 0. But 1 plus 1 actually results in 10, but we do not write it exactly as 10. We write the result as 0 and 1 is carried forward to the next digit. Similarly, I have written a note for you that if you have 3 ones at a place, 1 plus 1 plus 1, then the result will be 1, as 1 plus 1 will be 10 and 0 plus 1 will be 1 again, and 1 will be carried forward to the next digit. Now let's see some questions so that it will be more clear to you. Now the first question is 100 to the base 2 plus 101 to the base 2. As we know, we have only 4 possibilities for the addition of binary numbers. So while solving the question, keep those possibilities always in your mind. Okay. Now you have to write it as you perform the addition in decimal number, like I have written it here. Okay. Now we will start with the rightmost digits. The rightmost digits are 0 plus 1. According to the rule, 0 plus 1 is 1. Then we have 0 plus 0. Again 0 plus 0 is 0. Now we have 1 plus 1. 1 plus 1 is 0 and 1 is carried forward to the next digit. We will write 0 first, but since we don't have any digit in next, 1 will be written as it is. So the result of 100 to the base 2 plus 101 to the base 2 is 1001 to the base 2. Similarly, the next question is 11 to the base 2 plus 11 to the base 2. We will write it as it is, and we will start at 1 plus 1. So 1 plus 1 is 0. 0 is written here and 1 is carried forward to the next digit. Again 1 plus 1 plus 1 we have here. So 1 plus 1 plus 1 is 1 and 1 is carried forward since there is no digit. So we will write 1 as it is. So the result is 110 to the base 0. Now students, we will see how binary subtraction is done. Okay. When we have to perform binary subtraction, we have to follow some basic rules as we have done in binary addition. As in decimal number system, we have learned that small number is subtracted from the larger number, and sometimes we also need to borrow from the next digit, right? So all these rules you have to follow in binary subtraction also. Now, just as we subtract a decimal number from another smaller digit by borrowing from the next, we can also subtract binary numbers by taking 1 as borrow from the next column. Just like the addition, subtraction also involves 4 rules. Now these 4 rules are: when we subtract 0 from 0, result will be 0. When we subtract 0 from 1, result will be 1. When we subtract 1 minus 1, the result is 0. In the last, we have 1 subtracted from 0. Now we have a problem here. Problem is 0 is smaller than 1. Then how we are going to subtract 0 from 1? Now to do this, we have to borrow 1 from the next digit and subtraction will be performed and the result will be 1. Okay. But the digit from where we have taken borrow, that digit would become 0 after giving borrow to the digit. So let's now solve some questions so that it would be more clear to you. Now the first question is 1111 to the base 2 minus 1010 to the base 2. Now we will write it like this as we perform subtraction. Now we will start with the rightmost side. 1 minus 0 we have in first, so 1 minus 0 according to the rule it is 1. Then we have 1 minus 1 which will be resulted to 0. 1 minus 0 which is 1, sorry. And then we have 1 minus 1 which is 0 again. So the value of subtraction of 1111 and 1010 is 0101. Second question is 11101 to the base 2 minus 1011. You can also say it like this, that 1011 has to be subtracted from 11101. So now we will write it like this. So we will start with the rightmost side again. It is 1 minus 1. It is 0 here. Now the problem is we have to subtract 1 from 0. So according to the last rule which I had discussed in the last PPT which was there, we have to borrow from the next digit. So we will borrow from 1 and it will become 10 now. 10 minus 1 will become 1. Now when we will come to this 1 minus 0, this 1 has turned into 0 now. Now 0 minus 0 is 0 again. 1 minus 1 is 0 again. and 1 will be written as it is. So the value of 11101 minus 1011 is 10010. Now this was all about binary addition and binary subtraction. I hope you will understand today's lesson well. Now based on today's lesson, there is some homework. You have to perform binary addition and binary subtraction. For binary addition, I have given 4 pair of numbers, and for binary subtraction, I have given you 2 pair of numbers. So complete this homework and send it to my email ID till Wednesday 5 p.m. Okay. I'll start binary multiplication and binary division in my next video. Thanks for watching it patiently. Stay healthy and stay safe. Keep learning.